So I'm seeing that right side up. How are you guys seeing it? Are you seeing it normal or are you seeing it backwards? I need someone to actually respond to me because it's normal. Okay, perfect. So testing for symmetry, you saw in the ed puzzles we talked about what symmetry was in the second ed puzzle. Now I'm going to show you how to test for symmetry, and then I will talk to you about circles, and then I will send you on your merry way. I will post the assignment, and then you can get to work on that. Hopefully it won't take the whole class period, but it may. So when we're testing for symmetry, for example, we have the question test y equals 2x cubed for symmetry, right? It might say with respect to the axes and origin, it might just specify what kind of symmetry it wants, but we are going to do it both ways, right? We're going to go with respect to the axes. So that means test for symmetry about the y-axis and test for symmetry about the x-axis, right? So we're going to test for symmetry with respect to the axes. The axes are just the x and y axis. Axes is plural. And the origin, right? So I'm given the problem already, right? I have y equals 2x cubed. So to test for symmetry, it means I have to test for symmetry on the x-axis, the y-axis, and the origin. I have to do all three of those separately, right? So we're going to start with the x-axis, right? So the x-axis, if you remember from the video, it meant that we have, if we change our y to negative y, it's going to hold true. So here's our original equation. We have y equals 2x cubed, right? And what we need to see is if negative y equals 2x cubed holds true. Does that make any sense? And I can look at these. I don't need to plug anything in. I can look at these and tell you that they're not equal statements, right? Because now we're saying that 2x cubed equals negative y, and that is clearly not a true statement because y, 2x cubed equals y. Those are not equivalent statements. So because it's not an equivalent statement, we're going to say that there's no symmetry, right? We can look at that and go, okay, these are two very different things, right? One is saying that y equals 2x cubed, right? Which is the same as saying that 2x cubed equals y. This one is saying that 2x cubed equals negative y. Those aren't the same statement. They aren't. So it is not true. It is not symmetric. With the y-axis, we're going to do a similar thing, only we're going to make x negative, right? So my original equation is y equals 2x cubed. And now we're saying if we make x negative, which I hope you remember from your ed puzzle, that we're going to get a true statement. So we're going to look at this and we're going to go y equals 2, and we're going to make x negative and cube it. Notice that I put that x, that negative x, in parentheses because I want to know that that negative is being cubed as well. And when you think about this, this is going to give me y equals negative x times negative x is positive x squared times another negative x, right? Because we're cubing it, would give us negative. So we're going to get negative 2x cubed. And we have to look at that and go, is it the same as this? Right? Clearly it's not. We have that negative in front of the 2, so it's changed things up a little bit. And so again, we have no symmetry, right? This is no symmetry about the x-axis. This is no symmetry, oops, about the y-axis. The last thing we need to check is the origin, right? And if you remember correctly, I don't know, or if you remember at all, when we're talking about the origin, we make both x and y negative or opposite of what they were, right? So when we're testing for the x-axis, we make y negative. I don't know if you can see that. When we're testing for the y-axis, we make x negative, right? When we're testing for the origin, we make both negative, right? And then we're going to plug it in. So our original equation is y equals 2x cubed. And when we plug it in, we're going to say negative y equals 2 times negative x cubed. And if we look at this, we can go, okay, well, negative y equals, again, this just gives us negative 2x cubed, negative 2x cubed. These are equivalent because if I divide or multiply both sides by negative 1, which I can do as long as I do something to both sides, I can do it, right? I would wind up, right, if I divide this by negative 1 and this by negative 1, I wind up with y equals negative 2x cubed. These are equivalent statements. Sorry, not negative. If it was going to be negative, it wouldn't be. So this is symmetric. And when it asks you to test for symmetry, that's what it's asking you to do. It's asking you to go through, make y negative, see if you get a true statement. Make x negative, see if you get a true statement. Not even a true statement, an equivalent statement. See if it takes you back to the original equation. The origin, make them both negative. Does it take me back to this original equation? If the answer is yes, then it is symmetric. If the answer is no, it's not symmetric. Does that make any sense? Are there any questions regarding how to test for symmetry? I know you guys did the ed puzzles on it. Hopefully you took notes while you were doing them because it isn't a lesson. Does anyone have any questions regarding symmetry? All right. I'm going to assume that's a no. Move on to circles. I hope you're getting this. Nobody's talking. I can't see anyone, so I can't read your expressions. Can't wait until this online education is over. But since no one's talking, I'm going to assume you all get it correctly or incorrectly. I don't know. But we're going to move on to circles. Now, a circle, when you think about it, is a set of points, right? Circle is a set of points. Usually in the form xy, the way we're going to be using it, always in the form xy, that are in a plane. What is a plane? It's that xy graph that we're used to, right? Coordinate plane. And they are the same distance which we call the radius, from a point called the center. Now, this is the formal definition. When we talk about the center of a circle, we use HK. They're still just XY coordinates, but we call the center HK just to distinguish that it's actually the center. And the way that we can find the length of the radius is we use the distance formula, right? And we went over the distance formula, I'm pretty sure we did just recently. But think about this. So we have a circle, right? Okay, it's not the best circle in the world, right? And we're saying that XY is any point on the circle, and it doesn't matter which point it is, because technically every point on a circle is an equal distance to our center. So if our center is HK, that doesn't look like an HK on the screen to me, but it's an HK. So if our center is HK, anywhere on this circle can be XY. Doesn't matter. I could put it here. I could put it here. It doesn't matter because it's a circle no matter what, right? They're going to be the same distance from the center. Any point on this circle is the same distance from the center. So I'm going to put it right here, and I'm going to call this point XY, right? And the radius is this distance between them. Does that make sense? Is everybody following? I hope so. I hope you are. So the way that we came up with the equation of a circle, which is what you're going to have to learn to write, is by taking these points and finding out what R is. So think about this. This is a point, and this is a point. R is the distance between 2 points. We know how to find the distance between 2 points. We know the distance formula, D equals the square root of, what was it, x2 minus x1 squared plus y2 minus y1 squared, right? Well, think about this. What do I have? I have 2 points. I have an x1, y1, x2, y2. What am I looking for? I'm looking for the distance. Well, that's just my R, right? So when you think of it in terms like that, you can understand how we come up with how to find our radius, right? If you think about it, our radius, finding the length of our radius would just be R equals x minus h squared, right? One is just x1, the other one is x2, plus y minus k squared. Same thing, right? We just changed the letters, but it's the same thing. It's just saying that we're making our center x2, y2, right? Well, in this case, I think it'd be x1, y1, right? And x, y would just be x2, y2. Does this make sense as to how we got it? How we figure out what our radius is? And what we did was we used this to come up with the equation of a circle. So if I want to get rid of this square root sign, I would have to square both sides, right? I would have to square R, and I would have to square this, and I would get that R equals, well, R squared equals x minus h squared plus y minus k squared. And that is the equation of a circle. That is the standard equation of the circle. It's saying that x minus h squared plus y minus k squared equals our radius squared. And we came up with the standard equation of a circle. Can't spell today. Standard equation of a circle. We came up with it using the distance formula. What you guys are going to have to do today with your web assignment is you are going to have to take things and put them into the standard equation of a circle. Does this make sense? I am going to take you through it. I'm going to take you through an example. All right, maybe two, depending on how you're getting it. But like I said, I'm recording this video, so you will get to see it. You can go back and run it back. I'm not going to post it as an ed puzzle, so you don't have to answer questions to see it. I'm just going to post it into PowerSchool so that you have access to it. And I'm going to show you how to write the equation of a circle given information. So, writing the equation. Man, I feel like I'm talking to myself. Sometimes it's better to do this as an ed puzzle because at least I don't expect. And I know there's nothing you can do. Writing the equation of a circle. I'm going to get a better pen, so maybe it's a little bit more legible. So our example is going to be if a point 3, 4 lies on a circle, with a center of 1, 2, negative 1, 2. Write the standard form of the equation of that circle. I'm going to start doing these as like PowerPoints with the questions and stuff all written out already, so it's nice and neat instead of you having to do because I think I'm going to start using Canvas where I'll just have you log in while I do the lessons. So when we think about this, what do we have? We've got 3, 4, which lies on the circle. So 3, 4 would be our x, y. Then we have the center at negative 1 and 2. So that would be our h, k. So the one piece of information we don't know yet is our r, right? And the way we find that is we're going to have to use the distance formula. We're going to have to use r equals the square root of x minus h squared plus y minus k squared and figure out what our r is. And all we have to do is plug these numbers in. We know what x and h and y and k are. So that's easy enough. We can just plug in the numbers. We've got x minus h. Well, x is 3 minus h, which is minus 1. So I'm going to write that as minus 1 squared, plus y. Y is just 4, so we're going to plug in 4, minus k. Oh, I wrote k, but I should have wrote 2 squared. And now I can solve this, and I can figure out what my r equals. So again, 3 minus 1 is the same as saying 3 plus 1. 3 plus 1 is 4, right? And when I square that, I get 16. Then I've got plus, 4 minus 2. 4 minus 2 is 2. When I square that, I get 4 So I know that r equals the square root of 20. And I can leave it right now as the square root of 20. Right? Because that's all I need to know at this point is what r is. And so now I have to look at the equation of the circle, right? And we can write it down here. We can write the equation of the circle, which is x minus h squared plus y minus k squared equals r squared, right? So all we have to do now is plug in all our numbers. We know what they are. We know what x and h are, right? We know 3, 4 is x and y. We know that -1, 2 is h and k. And we know that r equals the square root of 20. We know these things already. We were given the first two, and then we just found that r equals the square root of 20. So now all we have to do is plug those things in at this point, right? So when I am doing this, we want to do it for any generic xy. So once we found r, these points don't matter. We can just use xy because it will be true of any point on the circle. Does that make any sense? I just want to make sure that's clear. I don't have to use 3 and 4. Any point that lies on that circle is going to be true to this. So we're just going to use x and y. Does that make sense? I hope that makes sense. So I can write this now as x minus h. Well, what is our h? It's -1. So I'm going to write that as -1 squared. Plus y minus k. What's our k? Our k is 2 squared. Equals r squared. Well, our r is the square root of 20. When I square that, it's just going to be 20. So now we just simplify all of this. X minus -1 squared is the same as saying x plus 1 squared. Y minus 2 is going to stay the same. So we've got plus y minus 2 squared equals the square root of 20. When I square the square root of 20, when you square anything that's already a square root, you just wind up getting the number underneath. And so this right here is our equation of the circle. Does that make sense to you? Would you like to see another example of it, or do you feel like you've got it from what we've done? You got it? You feel like you got it? Okay, well, here's what's going to happen. I'm going to switch cameras back because that's all I've got for you as long as you don't want another example, although I have another example. Let me just switch cameras back so that I can see you people or your names. Anyhow. I don't know why I can't get you in the grid anymore. Oh, I have to unpin me. There we go. There y'all are. Hey, Diego. How's it going? It's nice to see another face. You and William are my only two people I'm going to recognize when I actually see you in person, even though I know almost all of you. So that's all I really have for you today. I do have the WebAssign assignment, right? You can go right into WebAssign and do it. I will put the link up in PowerSchool under the agenda. I'll make you guys a quick agenda talking about us doing this lesson that we did. My computer's making a weird noise. And then I'll give you the link to WebAssign. But if you guys know how to get into WebAssign, you can get there and start working on it at any point because it's already been scheduled. It will be your only assignment for this week. Thursday, when we come in, it'll be brief. I will ask y'all how you're doing. If you need any help, I will help you with anything you need. But then next week, we're just doing the MDTP testing. Remember, it's a 0 or 100. You either show up and do it and get 100, or you don't show up and get a 0. All right? Those are the only 2 scores you can get. Takes place both days. So if you have to miss one, hopefully you'll get in for the next one. But I really hope you're in for both days because it's kind of a 2-day thing. It's not something you can really do in a 1-hour session. But so next week is going to be super light. Make sure it's just a diagnostic test, Judith. I think I gave it to everybody last year. It's a readiness test. It just helps me to know how to teach you a little bit better. So if that makes sense, it shows me what you do and don't know already. So that's why I'm not giving you an actual grade for it. I'm just I'll give you a grade. If you do it, you get 100%. If you don't do it, you get 0. It won't be make upable. You have to show up to at least one of those 2 days, preferably Tuesday, so we can get it all done and everyone can have the rest of the week off. But it's just I don't want you to worry too much about the test itself because how well you do won't affect your grade. But I would really appreciate if you try because it gives me an idea of what you do and don't understand. Right? But that's really it. The only thing I have for you this week is the WebAssign. Check in, make sure and show up to check in on Thursday. I will have a check in for points. It will be easy if you show up and do it. If you don't show up and do it, you cannot get the points. So that way I can at least check in with all of you guys and know what you do and don't know. So other than that, I will see you guys on Thursday. For sure, come in. I'll make sure it's worth your while to come in. I mean, even if it's just a thing where I ask your name to get the attendance, because we got to keep track of y'all a little differently this year. So, does anyone have any questions for me? No? If you don't, you are free to go, and I'll see you Thursday. If you do, I'm going to stick around until everybody's gone, so not to miss anything, okay? Look at y'all just disappearing. Look, there's my 2 that stick it out to the very end.
We like talking. We like you the most. Parties.
What was that sound, Aurora? What's going on in your background?
I think it might be TV.
Oh, it was Caitlin. It was her TV.
Oh. Not my TV. I don't have one. Well,
you don't have a TV?
I was like listening to stuff for background noise while taking your notes.
How did the notes go? How did you guys feel about it doing it that way?
Well, I could have used another
example,
but everyone was saying that they didn't, and I was like, I already know you guys are going to be asking for help.
Well, here's the thing. I can still do another example with you guys if you want it.
I mean, I think I understand it, but I just don't want to like be confused and then have to write you again and be like, Miss Hoy sent help.
Well, I'm happy to do another one if that will help. Caitlin, what were you saying?
I got it pretty well, but another example would be useful.
Okay, well, why don't I do another one? I mean, I've got everything set up here. I just have to switch the camera.
Oh, and I got you. I'll put my camera on for you. It's really dark in here, so you're only see like the outline of me, but I got you.
I see your silhouette.
Yeah, it's really dark here. I mean, I can open my curtain. It's just dark.
But I'm gonna move my face away, so now it'll be your faces, but not mine.
It's okay. I know how much you hate talking to screen, like.
Oh my gosh, it's so hard to not get any kind of a response.
I know. I try to respond as much as I can.
I don't like if I went on webcam, everyone would probably stare at me, and I'm just like, oh, I don't like that.
Well, no one can stare at you. You're in the dark.
That's true. But when I have my light on,
I think nobody does it because literally we get told not to put our cameras on in every other class.
Well, it does slow things down. So I understand that because it slows down. It causes a lag. I'm going to start using Canvas, I think, a lot for presenting the math lessons to help. I've been waiting for us to get these tablets because I'm left-handed, and it is really hard for me to write on screens because my hand touches them and then it messes it up. So I'm hoping that these new tablets that they ordered us will help with that, because it'll just be for that. And I'll make like little PowerPoints with the problems and stuff in it and the definitions written out so it's more legible. And then, oh, I'm still recording. Let me stop recording here really quick.